starting. All attendees are in listen-only mode.
Hi everybody, this is Miranda. Thanks for joining. I'm in the office. I am in the conference room. Hopefully you all can hear me and see my screen okay. I am presenting again today alongside Fred, who's working from home, and so he'll be talking through some slides just like we did last week in anticipation for today's potential severe event. And yeah, we'll keep this short and sweet. There'll be a recording that we'll post to YouTube as well. So hopefully this is a lot smoother than last week. Now that we've done this once, we can be a little bit more efficient this time around. So what I will do though is I am going to stop the recording once at the end of the presentation so that we can answer any questions that you may have, and so that those won't be a part of the post to YouTube. So with that, I'm going to go ahead and get started, as long as I can do this right. Okay, great. So again, thanks for joining. We're talking about today's severe weather potential. We already had a little bit of rain shower, an isolated thunderstorm here and there moved through early this morning with a leading short wave, and now we're setting the stage for potential slight to even enhanced risk for severe weather later this afternoon, more so probably in the evening time frame. Here's the latest SPC Outlook, and it shows that majority of our area, of our forecast area here, is under a slight risk for severe weather. Just parts of extreme the western portions of our forecast area across east central Ohio is under an enhanced risk, and then points west across especially Detroit areas under a moderate risk for severe weather today. Over to the right, here's our 5% chance for tornado activity. That was slightly moved to the east to cover more of our forecast area across east central Ohio. Over here on the far right is our wind threat today, again with an emphasis across the western portions of our forecast area, and then our hail risk as well on the bottom, which encompasses the entire forecast area, as well as the wind, and really as well as the tornado threat. But we can kind of talk to why maybe more so that is centered west of us, and it really has to do with the location of the closed low that's responsible for our weather today and the cold front that will eventually move through. Here's the 12Z sounding out of Pittsburgh this morning. A few things to note is our precipitable water. I put out a tweet earlier because it was amazing to me that just in a 24-hour time period, we went from just over half an inch of precipitable water to over an inch and a half of precipitable water, and I'm sure everyone can feel it. So with that, we've got the moisture primed. We also have decate values that we mentioned last week around closer to 1,000 joules per kilogram. So even though the sounding doesn't really look like there's a ton of dry air, there is, and there will continue to be dry air aloft that will assist in the development of damaging wind potential later. So just make note of that. I also here talk about the convective temperature. On this forecast sounding is 88 degrees today for Pittsburgh. Our forecast high is 90 degrees, which is in the grids right now. That's our high, what we're anticipating. So we are expected to reach and exceed our convective temperature. You can see we have this mid-level subsidence that's evident here, right around 700 millibars. And what I mean by that is this little inversion, and this is evident because of the shortwave that has moved through earlier this morning. With every shortwave activity, you would have a little bit of subsidence on the back side of it, and that is what the models are showing to persist into the afternoon, which is why we believe that we will be largely stable, if you will, generally speaking, into the afternoon ahead of that cold front, with the bulk of the activity coming with that cold front. It really has to do with that warm mid-level here, and that's really thanks to the leading shortwave that came through this morning. So I've got this wrap analysis. This is valid at 19Z. This is an AWIPS display, one of my displays here that I took a screenshot of, because I think it shows the leading short wave, this is vorticity that's shaded in the light green here. This was the initial short wave that's moving through. It's kind of getting hung up in the ridges because of this strong ridge to the east, and you can see it's lingering here. So this is valid at 19Z. So even though you know, it's 10 a.m., the shortwave doesn't progress a whole lot to the east, and this will serve as the mechanism for additional development across the eastern ridges this afternoon, early this afternoon, and it starts to show some of that convection developing across that region as of 19Z. But notice our big system here, the closed low, is still back towards Illinois, and the cold front associated with that and the precipitation is still across eastern Indiana and western Ohio. So this is valid again at 19Z. So you can see we're kind of in this hole, for lack of better terms, where some of our eastern areas could start to see some pop-up of thunderstorms, and then as that moves off to the east and becomes more of State College's problem, and then we'll be looking to the west here to see the breakdown of stability and that warm air aloft, or that warm air at mid-levels, to see how well it can keep us stabilized ahead of this system. This is a 500 millibar analysis, RAP analysis. It's pretty similar to what I just showed. I just thought it showed a better visualization of the leading shortwave trough here, which I'm outlining with my mouse. You can see a little bit of ridging, which is kind of what I'm seeing here in the heights across western Pennsylvania and eastern Ohio, and then the better forcing for ascent well to our west. This is jet support here. 300 millibars would show that you have a lot of divergence aloft here, all associated with this closed low. So again, just showing that through 18Z, the ensemble members here, this is the HREF ensemble, are in fairly good agreement with thunderstorms firing up across the ridges with that leading shortwave, and really putting us in this hole out ahead of that main frontal system as that comes through. So fairly good agreement in that. So I'll show you what that looks like from a sounding analysis in Buff Kit. We'll start with Zanesville, and here's Zanesville at 18Z. I have the model reflectivity. This is the NAM 3 kilometer to coincide with it, just so you can get an idea of why there aren't thunderstorms firing up at this time. And despite instability aloft, note here's 700 millibars, and we have that mid-level inversion or warm air aloft that's really helping to inhibit our ability to see that surface-based convection. So with that, despite that, though, we do have instability. We have CAPE values upwards of 1,700 joules per kilogram. We've got dry air aloft. We've got a pretty decent veering wind shear profile starting to develop here as this jet is becoming noticeable across eastern Ohio. But it's going to take larger lift and perhaps frontogenesis with that front as it comes through to really get convection going. For Pittsburgh, the mid-level cap is actually a little bit more evident, and the forecast soundings are all pretty consistent, showing a larger capping inversion across Pittsburgh. So we're a little bit farther away from the jet support here than we were in Zanesville, but nonetheless a little bit more stable by 18Z for Pittsburgh. A different story for Latrobe. They are further to the east in the mountains or in the ridges. They're a little bit higher in terms of elevation, and they're also seeing more of an influence of that shortwave, that leading shortwave. So notice their instability is surface-based, which is why at 18Z we're starting to see some thunderstorm activity start to trigger across the ridges. Note though, through all of these soundings, the convective available potential energy generally stays the same, as well as our ability to reach our hail growth zone and surpass our hail growth zone, as well as the dry air aloft too. So those threats, no matter what develops this afternoon, remain constant throughout this event. We talked last week about the SFC Delta Theta-E in overview in Buff Kit, and here is an example of what that looks like from Pittsburgh. You'll have to bear with me. My bar here at the bottom kind of goes backward from what you would intuitively expect. So this is valid 6Z Wednesday, and then this takes us to 12Z Wednesday. So this is now, give or take, right here. And what I'm showing is that as we move through the afternoon and then through 0Z tonight, we have plenty of that dry air available to produce downburst type wind, damaging wind. Last week we said to look for values above -20, and we have values here around 20, upwards of 35. So that is showing up in all the sounding overview across our area. I'll end it here briefly by showing the ensemble members, the HRF ensemble members, valid at 2Z, just to show why our confidence is higher and the thunderstorms becoming more widespread as we head toward the late afternoon hours across eastern Ohio, and then more so the evening time frame as we cross into the West Virginia, Pennsylvania border and then points east. You can see all the ensembles are handling this line of thunderstorms fairly well in terms of location, give or take about 3 hours on either side. But nonetheless, this appears to be the main show tonight. With that, we would expect the same in terms of potential hazards, hail, wind, and even embedded tornadoes, depending on storm motion. We look back really quick. I can show our hodograph. They are curved here across most of across our area. So what we would look for in order to ingest the most streamwise vorticity, we would want to look for specific storm motion, maybe closer towards the northeast, which is why the further west you go, those tornado chances increase. So more so across Detroit, central Ohio, a little bit less as you head towards our forecast area, simply because the storm motion will be a little bit different and won't be able to ingest the streamwise vorticity as efficiently. But we would want to keep an eye on any embedded rotation within this line because there is available helicity to perhaps induce maybe some quick brief spin ups. Lastly, I'll show this AWIPS hail tool. You guys don't have access to this with AWIPS, but Matthew, our Sue, we always look at this tool that he likes. I think he helped develop. Fred can correct me if I'm wrong, but what we look at is basically we're looking at the height of the 50 dBz core because that tends to translate to where we have the potential of observing severe quarter-inch hail. So with the hail tool as of this morning, what it's showing here on my numbers is we would want to look for a solid dBz core. I'm not talking just like a one speck of 50 dBz, but like a large core of 50 dBz to exceed about 33,000 feet, upwards of 36,000 feet, to really get into that hail growth zone, to allow large hail to develop and be lofted in the updraft and then eventually reach the surface. So this is when we talk about this in the chat, when we do chat injects, this is what we're looking at. Now this may slightly lower as our upper levels cool with that upper level low as it moves through, but that's the kind of convection, deep convection that we will be looking for today when considering whether or not we should be issuing severe thunderstorms. So the severe thunderstorm warnings. So what I'm going to do now is Fred said I need to unmute him. So Fred?
Yeah, I'm here, Miranda. Can you hear me?
Yep, go ahead.
Okay. Yeah, so great overview. And wanted to kind of add to Miranda's thing. So, when we issue warnings for severe thunderstorms for hail, the tool that Miranda just showed you makes things very straightforward for us. When we see large clusters of 50 dBz, to that level. And then also when she talked about the Delta Theta-E from that buff kit with values greater than -20. So again, so this afternoon we'll be looking for potential downbursts. If we see, clusters of 50 dBz pixels getting into that 15,000 to 20,000 foot range, that may not produce hail, but that can produce damaging wind. So that's part of the storm interrogation that our radar operators will go through later today. Okay, so we'll go back to the CIPS slide. And again, I showed this last time. I put the links in the slide. Again, this is kind of like deja vu here. Again, it's windy. It's going to be, so hopefully not too much dry air mixes down like we had the last slight risk a week ago. But the images kind of show you that they're really pegging on Indiana, Northwest Ohio, and Michigan, kind of where the moderate risk is for the greater than one severe weather event report. Over our region, the greatest probabilities across eastern Ohio, far west central Pennsylvania, with 50%, again, less than what we saw last time. But, again, we'll see what happens with this. And then the greater than 5 reports, again, the CIPS Analogs isn't too keen on this. But, again, this is also from a remnants of a landfalling tropical system. So there's probably not a lot of cases that it can gather that have this kind of synoptic setup. So we'll go to the next slide. One of the things I kind of try to show something new every time. So this is the NAIPS percentile plot. This is the huge, large ensemble, the North American ensemble forecast system. And I kind of showed the image here. This is the table for Pittsburgh. This shows you all the percentiles of the different wind levels across the atmosphere this afternoon around, or actually 6Z tonight. And one thing I have this gray arrow denoted is that given the 30-year historical period, for this date, this is the max 700 millibar wind speed that the NAIPS analyzed in its period of record, which is only about 30 years. But again, if you look at the 700 and look at the 500, again, large wind anomalies. So again, the threat for damaging winds exists with this landfalling, the remnants of Cristobal. The link again to this is at the bottom of the page. Go to the next slide. Also, the SPC climatology, you might have seen this on their main page. Just to give you an idea, so this is the probability of seeing severe weather on this date. You can see the bullseye across west central Ohio, and even a higher lower bullseye, but still an elevated threat across western Pennsylvania and much of Ohio. So again, so the probability of seeing severe weather today is around 5% historically, using the 1982 to 2011 averages. So in our SPC progs for wind and hail, the highest probability is 15%. So again, to kind of put this in perspective, again, and we always try to relate things to the past events in climatology, it's a 3 times greater risk than we normally would see on a day like this. So again, everyone's doing a great job messaging this to the public. So again, it's something to kind of show you how much of an elevated day this is for our region. Go to the next slide. And then now this is one thing that you may not be aware of. I try to throw in maybe a golden nugget if you don't know about it. WPC, the Weather Prediction Center, produces like this nice graphic of storm reports, and you can customize the day, time, your latitude, longitude for your area of region that displays them. I know your weather vendor may incorporate these into your graphics, but again, just another way to kind of see all the hazards that are going on, not only for just severe, but also for flooding, snow, and non-thunderstorm winds. Next slide. And then lastly, again, tropical systems are kind of wild cards, so I'm not sure how many people remember Hurricane Ike that came through. Again, it went through Houston, then kind of up through the Ohio Valley, and then kind of towards Detroit. And Cristobal was kind of tracked a little bit further east and went due north. But again, it caused a lot of power outages, mostly from synoptic winds mixing down. And, again, we had, numerous power outages across Ohio and western Pennsylvania. So again, wild card, these tropical systems are wild cards. So we can't just assume this is a normal weather system. And if you look at the wind advisories and high wind warnings that were in effect yesterday, Oklahoma had northwest winds synoptically gusting over 70 miles an hour. Today, there's a wind advisory for northwestern Louisiana. And typically, you wouldn't see a wind advisory on a clear weather day for northwest Louisiana in June, as we think that the jet stream all moves further north and the storm track moves further north. But again, landfalling tropical systems are very challenging. So again, just kind of keep that in mind as we go through this event today as it unfolds. You might say, well, why did this happen, or why did this happen? Again, it's there's a different characteristic as this thing goes from tropical to more of a mid-latitude system. And with that, I think that's all we have, Miranda.
Yeah, that's it. So what I'm going to do is, if I can do this, right, is stop recording this.